Welcome to Networks Professionals.
Welcome to this explainer. Today, we're diving straight into the invisible corporate structure that keeps our entire digital world humming along smoothly. We rely on networks literally every single day, right? Sending emails, streaming, connecting across the globe, but we rarely stop to think about the underlying nervous system keeping all that hardware in check. So let's bring that hidden infrastructure right to the surface.
Let's kick things off with a deceptively simple question. How exactly do millions of routers, switches, servers, and printers stay organized without just descending into total chaos? I mean, imagine a massive global corporation with millions of employees, but zero managers, no communication, and no rules. It'd be an absolute disaster. Well, computer networks face that exact same logistical nightmare. They desperately need a system to manage all that digital traffic.
And the answer to that potential chaos? That's SNMP, or the Simple Network Management Protocol. Think of SNMP as the ultimate corporate oversight system for your network. It's a standardized application layer protocol sitting right up there at the top at OSI Layer 7. Its entire job is to monitor, manage, and configure devices within an IP network. So whether we're talking about a massive enterprise server or, that printer down the hall that always seems to need toner, SNMP is what tracks its performance and catches faults before they turn into catastrophic failures.
Now, there are two very specific numbers you need to keep in mind here, 161 and 162. These are the exact UDP ports where all this management magic happens. You can really think of these ports as the dedicated hotline numbers for network management. When devices need to talk about their health, update a configuration, or flag a potential problem, they basically pick up the digital phone and dial in on these precise channels.
Moving on to Section 1, meet the network management team. We need to figure out exactly who is talking on these hotlines.
Here's the core power dynamic within SNMP. On one side, we have the SNMP manager. This is your centralized CEO. It's the overarching system looking at the big picture, actively monitoring and managing devices all across the network. And on the flip side, we have the SNMP agent. Think of the agent as the department manager. Now, this isn't some separate piece of hardware. It's software sitting natively right on the managed device itself, like your router or switch. The agent's job, to collect local data on the ground and report it directly back to the CEO.
But you might be wondering, how does the agent actually know what to report? Well, that's where the MIB comes into play. MIB stands for Management Information Base. If the agent is the local department manager, the MIB is basically their official employee handbook and ledger all rolled into one. It's a highly structured database living on the agent that explicitly defines the variables that can be monitored. It dictates the exact rules of what info exists on that specific device and how it has to be organized for the manager to actually read it.
All right, Section 2, the language of SNMP. Now that we have the corporate structure down, how do these components actually talk to each other?
There's a very rhythmic communication cycle here, forming the core vocabulary of SNMP, and it boils down to three main operations. First up is the GET command. This is simply the manager requesting specific information from an agent. Get me the current CPU usage. Next is SET, which is the manager actively configuring the agent, basically saying, set the new bandwidth limit. And finally, and honestly the most interesting one, we have the trap. A trap is when the agent acts on its own to asynchronously alert the manager of a vital event. It acts as a sort of emergency panic button, like, hey, my cooling fan just died. It doesn't wait to be asked, it just fires off the alert.
Next up, Section 3, we're looking at the evolution of security. Because as you probably know, early networks were a whole lot more trusting than they are today.
Back in the day, we started off with SNMP version 1. It was the original pioneer, absolutely, but we rarely see it used today because its security was just incredibly low. It literally sent information in plain text, which is obviously a terrible idea now. Then came version 2C, which brought better performance and handled complex data much more efficiently. But the real game changer, the one we actually rely on now, is SNMP version 3. This current standard brought robust enterprise-grade security to the table, featuring strict authentication and actual encryption. So now all those GET, SET, and TRAP messages can't just be intercepted or spoofed by anyone listening in.
And that brings us to our final section, the big picture. Let's zoom out and look at why this invisible, automated middle management is actually so vital.
Here's the thing. Network administrators absolutely rely on SNMP to maintain their sanity and, frankly, the network's integrity. It allows them to continuously monitor device health, analyze exactly how network traffic is flowing, and rapidly detect faults through those asynchronous traps we talked about. Ultimately, it maintains the overall speed and performance of the entire network. It's the vital tool that ensures your everyday internet experience stays completely seamless. Without it, engineers would basically be flying totally blind.
So, we've unpacked the manager, the agent, the MIB, and the much-needed secure evolution of this incredibly vital protocol. I'll leave you with this. The next time you load a web page flawlessly, stream a movie without a hint of buffering, or connect to a secure corporate server, take a second to wonder. What silent, highly secure corporate conversation of gets, sets, and traps is happening inside your router right at this very moment to make it all possible? Thanks for joining me on this explainer, and keep questioning the tech that connects our world.
Thanks for watching.